Here are solutions to test number 3 for ECE 376. This test looks at interrupts and digital filters. Now all three questions are the same. You've got a game show, two players are hitting their buttons. Whoever hits their button first wins, and their light turns on. And you also have a way to clear it. The host can clear the lights. How do you do that? 3 different ways using interrupts. Now the first problem is using an edge interrupt. I've got 2 different players hitting their buttons. I want to use an edge interrupt to detect that edge, and if player A hits the button first, A's lights turn on, otherwise B's turn on. So with the processor, I can use a couple different interrupts. One option is INT0 and INT1 for the edge interrupts, corresponding to port B pin 0, port B pin 1. And button C is just any old pin you like port B pin 7. In the main routine, I could check that button. Anytime the host hits button 7, that clears the lights. If button A is pushed, I see a rising edge on button 0. That calls this interrupt. It says if B's light is turned off, then A's lights turns on. Otherwise, turn off A's lights. Clear the flag, exit. If B turns on, hits his button, then if A's light is off, turn on B's light. Otherwise, turn off B's light, exit. So that's one way. If both players hit the buttons at the same time, what's going to happen is the order. If I have this routine first, A wins on ties, otherwise B wins on ties. And it doesn't actually have to be a tie. It takes about 50 clocks to trigger an interrupt. So if A and B hit the buttons at the same time, give or take 50 clocks, whichever one you write first wins. One way to do it. Second way is a timer interrupt. I'm going to set up a timer to sample the buttons every n clocks. I will then check. If A's button is pushed and not B's, then A wins. If B's button is pushed, not A's, then B wins. If they're both pushed, I've got a tie. I'm not really sure what to do. The first one is how many clocks between interrupts. This is based upon your birth date. If it was 16,200 clocks, come up with A times B times C, that's close. A sub is limited to 1 to 16, integer. C has to be either 1, 4, or 16. B is 1 to 256. That sets up the number of clocks between interrupts. Then in the interrupt surface routine, every n clocks I check it. If button 7 is pushed, I clear the lights. If button 0 is pushed and port D is 0, then turn on A's lights. If button 1 is pushed and A's lights are off, turn on B's lights. Now in this case, A wins on ties, just the way I wrote the code. Well, that's another way, using timer interrupts. Third approach is using capture interrupts. This will detect a time difference of 1 clock, or 100 nanoseconds. So if A hits the clock first, and then B hits it 100 nanoseconds later, I can see that difference. So first, to measure time to 1 clock, 100 nanoseconds, I need a prescaler of 1. I'll pick a pin. In this case, I'm going to have port C, pin 2 for player A, port C, pin 1 for player B. And the main loop. If button 7 is pushed, I'm going to clear the lights and also clear my timers. I've got timer 1 running in the background. That's the time of the event. As long as the game lasts more than 6.5 milliseconds, I need a 32-bit timer. That'll be a 32-bit time. Then, inside the interrupt surface routine, if I saw an edge on A, I'll check. I'm going to first check the times. I'm going to see if A hit the button, record A's time. If B hit the button, record B's time. I'll then check the CU1. If A hit the button and B's lights are off, or A is less than B, then turn on A's lights. If B hit the button, there's B, here's A. If A's lights are off, or A did not hit the button, or B's time is less than A's time, then B won. If both A's time and B times are the same, this code kind of just skips over both of them. So on ties, neither one wins. If I change this to less than or equal, then A wins on ties, If that one's less than or equal, then B one's on ties. And this will be accurate to 1 clock or 100 nanoseconds. The last one is if I want to build a filter. Here's the filter in the S-plane. What's the discrete time equivalent? So convert from the S-plane to the Z-plane. One way, the approach I like, is the mapping. Z is e to the st. So I've got 1, 0, 3 poles in the S-plane. I've got 1, 0, 3 poles in the Z-plane. The pole at minus 40 maps to the Z-plane as e to the st, 0.5488. The pole at minus 2 maps to the Z-plane as 0.9704. Pole at minus 12 goes to 0.83. Pole at minus 14 goes to 0.81. To find k, match the gain at some frequency, like DC. At DC, the gain of g of s is 0.71. Pick k to match the DC gain. So here k is 0.0017, and there's g of z. That's test number 3 for ECE 376.